guys, I'm Cameron Landers. Thanks for watching. This video is part of my sound engineering video series. You can find all the videos in the series on the Cameron's Studio channel. My top 3 sound engineering tools video included a high-level introduction to compressors. In this video, we'll delve more deeply into compression, related terminology, typical features of a compressor, and more detail on how to use compression to achieve its intended purpose. As I mentioned in my top 3 tools video, a compressor measures and reacts to amplitude. On an oscilloscope, amplitude is a measurement of the strength or amplification level of a given signal. Amplitude is represented visually by the vertical height of the waveform on the oscilloscope. A taller waveform has a higher amplitude level, while a shorter waveform has a lower amplitude level. In human terms, amplitude is how loud an audio signal is at the point where it's measured. To start off, let's talk about the purpose of a compressor. The chief purpose of a compressor is to control widely varying loudness. For example, a singer may sing some parts very softly in the lower registers, and other parts may be way too loud in comparison as their voice enters the higher pitch registers. Generally, a singer will have more power to project in the high registers than in the lower ones. An electric guitarist or electric bassist may use foot-operated effects devices that drastically increase the perceived loudness characteristics of their signal at any given time. Compression is useful for that scenario. Similarly, a drummer may play very subtle nuances on the hi-hat or other cymbals at times, and then change to hard-hitting drum parts that can overwhelm the mix during a chorus. A compressor can be configured to kick in when parts are played or sung too loudly and bring them to a level of perceived loudness that balances better across the scope of the overall material from the perspective of the sound engineer. An experienced sound engineer knows how to apply just the right amount of compression to keep excessive loudness to an acceptable level while still maintaining most of the signal's natural dynamic range. A compressor has several settings that determine the conditions under which it becomes active and exactly how it affects the signal when it is active. This brings us to compression terminology. The first of these settings is the threshold. The threshold setting refers to a measurement of the decibel level of a signal. The term decibel is a unit of measure that is commonly used to measure perceived loudness to the human ear. A decibel meter is a device that measures the loudness level of ambient sound in any environment. This is accomplished using a specific type of sensor. Every compressor has a built-in decibel sensor, and it's one of the compressor's key internal components. The threshold setting determines the decibel level at which compression begins. Any audio whose level lies below the threshold setting will pass through unaffected. Any audio that is louder than the threshold setting will have its gain reduced or compressed to a level determined by the ratio setting. So now, let's define the ratio setting. The compression ratio determines how much gain reduction the compressor applies to the signal when the signal surpasses the threshold level. The resulting gain reduction amount is in comparison to the original signal loudness. For example, a ratio of 4:1 means that for every 4 decibels that the signal rises above the threshold, the compressor will decrease its output by 1 decibel. The next setting on a compressor is called the attack time. The attack time is how long it takes the signal to be fully compressed to the ratio setting after it has exceeded the threshold. For example, one might set a slower attack to create some punch from an instrument that's softer like a keyboard, or a fast attack might be used to quickly compress the sound of a loud guitar signal. Another setting on the compressor related to the attack time is the release time. The release time is how long it takes the audio signal to return from being compressed back to its original uncompressed state. At smaller compression ratios, fast release speeds sound the most natural. At higher compression ratios, a fast release time might cause an undesirable pumping effect, a sudden increase in the loudness that's very noticeable and unpleasant to the audience. Like so many things in sound engineering, it's a matter of balance between different elements of control. There are times when you might want a pumping effect. More on that later. Another commonly used term in compression is the knee, K-N-E-E. The knee is related to the attack time, but it's not the same. The knee is how quickly the compressor reacts and transitions from not compressing to compressing the signal. The knee takes place after the attack time, or you could even say during the attack time. The attack time determines how quickly compression is applied when the threshold is exceeded. The knee controls how the effect is applied within that attack time frame. Generally, we refer to two different types of knee. A soft knee will sound smoother because the compression begins more slowly or gradually, while a hard knee will sound more dramatic because it compresses with more of an all-at-once effect. Vocals sound better with soft knee compression. Hard knee compression is more often used for percussive sounds like the kick drum, piano, or other more percussive type sounds. Now let's talk a bit about output gain. When a signal is compressed, the output level coming out of the compressor will be less than that of the signal coming in due to the applied compression. Compression is gain reduction. Because some parts of the signal were reduced in a compressed signal, it affects the overall output level of the signal as a whole. Again, gain reduction. Output gain is also known as makeup gain because it's used to turn the overall level of the signal back up to its original level or to some optimum output level determined by the sound engineer. To determine how much output gain you need, you can compare the output gain of the compressed signal with that of the uncompressed signal. You can simply bypass the compressor to test the uncompressed signal on the fly. The idea is to boost the output gain of the compressed signal to bring it as close as possible to the same overall gain as the original uncompressed signal. Okay, now let's talk about different types of compressors. The most time-tested type of compressor, and the one that's been around for the longest, is the tube compressor. This type of compressor is used mainly for vocals, bass, and drums. The first compressors were tube compressors, and they're still used today, particularly when reproducing classic rock or other older music genres. Perhaps the cleanest type of compressor is the FET, or Field Effect Transistor compressor. FET compressors have transistor circuits that can emulate the tube sound without the noise associated with the older tube-based compressors, resulting in a fast, reliable, and super clean sound. FET compressors are used in the same genres as tube compressors for that reason, but they can also be used on many other types of material for different reasons. Another distinct type of compressor is the parallel compressor. In this scheme, the unprocessed signal is mixed along with the highly compressed version of the signal. This can reduce overall dynamic range by bringing out the softest sounds more in the mix. Another type of compression is known as sidechain compression. In sidechain compression, the characteristics of when the compressor kicks in and for how long is governed by some other specific instrument in the mix. For example, a sound engineer might use the kick drum signal to compress the bass, so that when the kick drum sounds, the bass stands out more in the mix. You may have heard this pumping effect in dance, pop, or trance, rave mixes of material produced by DJs, for example. Finally, a multi-band compressor allows you to split off multiple instances of a given track, each of which can be compressed independently. For example, a sound engineer may have a second copy of a vocal on a separate track from the original and use compression to reduce the mid-range boomy sounds on the second copy. This will have the effect of reducing the boominess of the overall vocal in the final mix because those tracks are mixed together while retaining its full range from the original copy. Multi-band compressors usually come into play on a final mix to ready it for mastering. Next, we'll discuss some of the most tried and true tips and methods for using compression. First, compression has a distinct purpose. You should never use compression without a specific identified reason. Some of the reasons you might opt to use compression include whether the background vocals or instruments are disappearing in the mix in some places, whether you need to bring out the attack to enunciate a vocal in the mix, or some other reason, and there are many. Just know there's always a price to pay for any added capability or effect. This includes compression. Compression reduces the natural dynamic range of a sound, so you wouldn't want to use it without a reason. The bottom line is, if you don't have a reason to use compression, don't use it. It can't solve a problem you don't have. Another tip for compression is to start small. Make subtle changes at first to bring out the instrument or vocal you think may need adjustment. This may validate or eliminate your concern. If you decide to use compression, use as little as possible to address the problem and only use it on parts that need it. In a studio recording, you can move the problem parts off to a different track and use compression only on those parts. Digital audio workstation software allows you to use compression plugins, which are extremely useful. You can enable or bypass compression for distinct parts of tracks, use different types of compressors for different types of material, or for different instruments. It's versatility at your fingertips. This wraps up our deep dive on compressors. Please check out our other videos in this series. And as always, please remember to like and subscribe to show YouTube that you find this content useful. Thanks for watching, and I'll see you in the next video.